Good afternoon, class, and welcome to Honors Geometry. Today we're going to be talking about, I'm going to actually touch base back on a concept that we covered in class today. Today we actually had our first discussion about proofs. So section 1.4 in our textbook, our objective is to actually write simple two-column proofs. Okay, so we're going to start our class out today talking about proofs and writing two-column proofs. But before we do that, let's talk about exactly what is a proof. Well, a proof is kind of like an argument. And when we have an argument, after we make a statement, we always back that statement up with a valid reason. When we're referring to a two-column proof, we're going to have a proof that's shaped like a T-chart. And on one side of that chart, we're going to have our statements. And every time we make a statement, we will back that statement up with a valid reason. Keeping in mind our goal is to reach a conclusion at the end. So after each statement, we'll back each statement up with the reason. And the type of reasons that we can use consist of something that's given to us. So it could be some given information. A reason could be a theorem that we've learned in class. It could be a postulate that we've learned in class, or an axiom. It could also be a definition. But what we want to keep in mind is that we use all of these reasons to reach a conclusion. So the first line of our proof should be followed with whatever information is given to us, but the final line in our proof should always be what it was we were trying to prove or what it was we were trying to conclude from that argument. So keep in mind, like, it's preparing you for an argument. Now, there are two forms of proof. Really, there are three forms of proof that we'll be seeing in our class. The most common form of proof that we'll be working with is going to be the two-column or the T-chart proof. And then after that, we will also take a look at paragraph proof, as well as you might see a flowchart proof here and there. But for now, let's focus our studies on T-chart proofs. So if you look at your notes today, we're going to begin proofs. The first thing that we talked about today is this whole ideal of what is a theorem. Well, you may recall from previous sections that we defined a theorem as a statement that can be proven true. So a theorem is a statement that can be proven true. And again, just to remind you, when we're doing our T-chart proofs, we use one of our reasons that we use could be a theorem. It could also be a definition, a postulate, or some given information. In our lesson today, we talked about or introduced some theorems. It's important that even though we're introducing these theorems, that you're aware you're not going to memorize those theorems as theorem 1, theorem 2. You're going to memorize the content in the theorem. The first theorem that we talked about in class today is if two angles are right angles, then they are congruent. So if two angles are right angles, then they are congruent. And we looked at a shortcut in class today. And then we used a proof, and we didn't use the flow chart. We used a T-chart proof to justify the following theorem. And they told us in our given information, they tell us that angle A is a right angle. So here on my diagram, I'm going to put the symbol that I use to identify a right angle. They also tell me angle B is a right angle, so I'm going to notate that with the symbol that I use to indicate that I'm dealing with the right angle. Then I'm going to go right into my proof. In my proof, again, I'm going to have one column with statements, the next column followed by reasons. And again, this is an argument, and that argument is going to build up to what do I want to prove. So I want to prove that angle A is congruent to angle B. So every statement that I make in my proof should ultimately be building up the argument to reach the conclusion that angle A is congruent to angle B. And I'm going to do that by starting with my given information. First thing that I'm given is that angle A is a right angle. And the reason I know that is because it was given. Because angle A is a right angle, I know that the measure of angle A is equal to 90 degrees. And I know that because that's the definition of a right angle. The definition of a right angle states that if an angle is a right angle, then its measure is 90. Next thing I know from my given information is that angle B is a right angle. And how do I know that angle B is a right angle? Because it was given. So I can either write given here, or I could put same as 1. From there, I'm going to say that the measure of angle B is equal to 90 degrees. And again, how do I know? By definition of a right angle. And that is the same as 2. And it seems like now I have enough information to reach my conclusion. And my conclusion is that angle A is congruent to angle B. And I know that. How do I know angle A is congruent to angle B? Because that theorem that says that if two angles are right angles, then they are congruent. Okay? So that sums it up for our first proof. Notice I started off with my given information. I used that information to create an argument. In that argument, I backed that argument up with valid reasons. Those valid reasons consist of definitions, theorems, postulates, or axioms, and given information. And finally, I reached my conclusion, which is what I want to prove. Okay? So let's look at the second theorem that is actually introduced in this lesson. I'm going to erase some of this so that we can focus in on the theorem 2. The second theorem that's introduced to us in our lesson today is theorem 2, and that theorem states that if two angles are straight angles, then they are congruent. I'm going to skip the shortcut because we discussed that in class today, but I am going to go right into the next proof. Notice in the next proof they tell me that ABC is a straight angle and angle DEF is a straight angle, and they want me to prove that angle ABC is in fact congruent to angle DEF. And I'm going to do that again by setting up a 2-column proof with my statements followed by my reasons. Statement number 1, again, I'm going to start with my given information. So the first thing that I'm told or given is that angle ABC is a straight angle. I'm also given that angle DEF is a straight angle. Some of you may put this together in one step. Some of you may separate it into different steps, and it's fine. It doesn't really matter. So I'm going to put it together in one step and all my given information. The next thing I'm going to do is, my next statement, I'm going to state that angle DEF and angle ABC and angle DEF, the measure of those angles is 180. And how do I know that? I know that by the definition of a straight angle. If it is a straight angle, then the measure is equal to 180 degrees. And then finally, I have enough to go right into my last step, that angle ABC is in fact congruent to angle DEF. And the reason that I know that is because, can you help me out here? We know that those two angles are congruent because the theorem that we were just introduced, if two angles are straight angles, then they're congruent. Awesome. Good job. So I'm going to move us on over. I want us to look at the next example. The next example, they tell me, I'm going to skip this example. We did it in class today. I'm going to come down to this example because the next couple of examples you were going to do on your own for homework tonight. So I'm going to cover those two examples before we sign off for tonight. So angle A is a right angle that's given to us. So I'm going to notice I'm taking that information. I like to draw it right on my diagram. Then they tell me that angle T is a right angle. So I'm going to draw that right on my diagram. They want me to prove that angle A is congruent to angle T. So now I've got my diagram here, and I want to prove that angle A is in fact congruent to angle T, but they've told me that angle A is a right angle and angle C is a right angle. So I'm going to go right into my proof here. I'm going to have my statements followed by my reasons. My first statement, I'm going to begin with my given information that angle A and angle T are right angles. How do I know that? Because that information was given to me. And again, you might have put all that information together in one step, or you may have separated that information and made that two separate steps. I feel like I have enough information because angle A and angle T are right angles. You may have an additional step that says the measure of angle A is 90 degrees, the measure of angle T is 90 degrees. But as we get more comfortable, we're going to start to eliminate that step. So I'm going to go right on into the last thing, that angle A is congruent to angle T. Do you guys remember why I can say angle A is congruent to angle T? You've got it. That theorem that we just learned today states that if two angles are right angles, then they are congruent. Not keeping in mind the number, but keeping in mind the content that was covered in that theorem. So again, if two angles are right angles, then they are congruent. All right, good job. So let's keep it moving. We've got a couple more theorems on the back that we need to cover today. So I'm going to move on to the next page here, and let's take a look. We've got a theorem on the back. So these were two of the theorems. The bottom one you did in class. We already talked about it, but let's look at these two. Let's look at this example here and this example here. Starting with the first example, they tell me that angle GKH is 38 degrees. So I'm going to find that angle on my diagram. Here's angle GKH. So this angle here is 38 degrees. They tell me angle KHJ is 38 degrees. So angle KHJ, that's this angle here. Notice I'm using these congruent markers to indicate these angles are congruent, but this angle is also 38 degrees. Then they tell me angle HKJ, angle HKJ, this angle down here, I'm going to use two tick marks. They tell me that angle is 51 degrees. And then they tell me that angle GHK, that's this angle down here, is also 51 degrees. They want me to prove that angle GHJ, which is this angle, is congruent to angle GKJ, which is that angle. So they want me to prove that those two angles are in fact congruent. So I'm going to kind of think about this ideal in my mind of what's going on for this particular problem as I approach it. And this might be a process that you do. First thing that I do is I label all my given information on my diagram. I start thinking about the process that I'm going to actually go through in order to prove what it is that I'm being asked to prove here. So as I think about that process, I can always start off with my given information. Again, breaking this up into statements and followed by reasons. So my first thing that I know, I'm going to start off with my given information. So I'm going to bundle my given information together. I'm going to use parentheses here because I don't have that much space, but these parentheses represent all of this information that's given to me. And the reasons that I'm going to have, of course, is because that information was given. From there, I can say that the measure of angle GKH, the measure of angle GKH plus the measure of angle KHJ So we can look at our diagram and see that I have one angle is 51 degrees and one angle. So I can see that the measure of angle GKH and the measure of angle plus the measure of angle HKJ is equal to 38 plus 51. That would be 89 degrees. And that is by the addition. That's just by addition. And then I can also see, if I add up the other angles, angle KHJ plus the measure of angle GHK also equals 89 degrees. And again, that's by the addition. It's because I'm adding those two values up. Well, when I add those two values up, I see that I get what? The same value. I get two congruent angle measurements. In this particular case, they are not right angles, but they are actually the same measure. So I could conclude that angle GHJ is congruent to angle GKJ. And the reason why I know that is because congruent angles have the same measure. All right. Let's move on. We got one more diagram that we were given that we want to talk about. This one looks kind of like one we did in class earlier today. So I'm given this diagram. That's all that they gave me. And they want me to prove that angle EFG, which is this line, is actually congruent to angle HFJ, which is this line. They want me to prove that those two lines are congruent, but all they gave me was a diagram. Well, I kind of want you guys to start thinking, because before we actually put it into a two-column proof, we should think about what is the process that I'm going to use in order to prove this. So you guys might be thinking, okay, what am I given? Because we always start with what's given. Well, I'm given the diagram as shown. Okay, well, what does that diagram tell me? The diagram tells me that angle EFG and angle HFI are straight angles. Well, how do we know that? Well, we know that because that's something that we were told in our previous lesson, that we can assume from a diagram. We can assume straight angles from a diagram. And then finally, I can conclude that angle EFG is congruent to angle HFJ. And why can I conclude that? Because if two angles are straight angles, then they are congruent. Okay, so we can pretty much wrap that up into a really short proof that I will write out in this manner. Again, with our statements followed by our reasons. I start off with step 1 is my diagram as shown. The reason for that is it was given to me. They told me that that was my given information. Because they gave me the diagram, I can conclude that angle EFG and angle HFJ are straight angles. Angle EFG and angle HFJ are straight angles. And why can I conclude that? I can conclude that because it was assumed from the diagram. And then lastly, I want to prove, I have enough information to prove angle EFG is congruent to angle HFJ. And the reason that I can conclude that is because if two angles are straight angles, then they are congruent. Awesome. So everyone notices for that particular problem how I kind of walked it through in my mind. and I kind of thought of that process in my mind before I actually put it down onto the proof. Well, that process that I went over is a great way to introduce you into this newer concept that we won't really talk about in class, but this whole idea, I'm going to introduce it to you in class, but it's really no new information. It's this whole idea called paragraph proof. In section 1.6 is more practice doing proofs, but it introduces a non-formal way of doing a proof, and that whole idea is called paragraph proof. So paragraph proof are not as formal as two-column proofs. If on a test you get a general idea of how to prove something, or you are short on time, you could revert to using a paragraph proof or write something in simplest form that you would solve in a proof. If you write a paragraph proof first, it helps you to organize your thoughts. So it's kind of an organizational method. Helps you to decide how to put your arguments into the two-column proof a little easier. So here's an example of where we might use a paragraph proof, and then how I can convert that paragraph proof into a two-column proof. So I have this given diagram that's given to me here, and they tell me that segment AC is congruent to segment BD. So segment AC, that's this segment here, is congruent to segment BD, which is this segment here. So now they want me to prove that AB is congruent to CD. They want me to prove that AB is congruent to CD. They want me to prove those two areas where I put question marks are congruent. So now, let's think about this. Again, we're going to think about it first. I see that I have two larger segments that are congruent, and I see if I were to subtract this smaller segment BC that both of the larger segments share, if I were to subtract that, this is the larger segment that they both share. If I were to subtract that segment from both of the larger segments, then the remaining segments would have to be congruent. Okay, so now there we go. That is the exact proof. So that argument, I just thought about that argument. I formulated it in my mind. I've written it down in a couple of bulleted items. Now I can translate that information after thinking about it into a two-column proof. So my two-column proof looks like segment AC is congruent to segment BD. It was given. Notice I said segment BC is congruent to itself. That's something called reflexive property. And next time we come to class, I'm going to pass you all out the properties just to read and jog your memory for what all of the properties are that you already know so far. I'm going to pass those out to you so you can look at those. And then finally, if I subtract the property that they have in common, I would get that AB is congruent to CD through the subtraction property. So this is all that I have for you all today. This is some of the content that we covered in class. And for homework tonight for section 1.4, I want you to look on page 26, and I would like for you to do problems 3, 5 through 7, 9, 11, and 15. Once you finish those problems, I'd like for you to proceed to the video on section 1.5, and then we'll have some practice problems there too. Thanks for listening, and have a great evening.